Good morning, everyone.
Good morning,
And
sir.
yeah, the recording has started. And let us move to. We have been doing the last section and try to finish it off today. Okay, it's not hard and fast again. Just like yesterday, we saw that a few discussions made us extend our session. Let us see how it goes about today. We were into what happens as far as surface waters of the oceans are concerned. And we said yesterday that these are operated by what you can call as, say, the wind speed or wind direction. It's the energy of the wind that
Sir, your
brings
voice
about
is really
this.
low.
My voice is low.
Yeah.
What
No,
about
sir.
others?
No, sir.
Okay, fine. So please check your volume controls at your end, please. So it's the friction of the wind that causes the surface layers of the waters to circulate. And while the water circulates, and just like what happens in conduction, the energy tends to transfer itself while the water stays where it is. But then we did speak about this yesterday also. How is it that we have these advancing waves? That has more to do with this particular energy being, so to say, concentrated into smaller and smaller areas like here and here. And because of that compaction, the energy climbs into what is called as a creeping crest, and then it's going to break into what is called as the breaker zone, and then the energy out of this breaking is further going to surf along the beach as such. So that's how it happens. This was what we did yesterday. It's propagation of energy, it's not propagation of mass. A few technical terms that we saw as far as a progressive wave is concerned, and we saw how in deeper waters, okay, the water particles tend to move in a circular momentum, while as far as sorry, as far as shallow waters are concerned, this circular movement is compressed, and that leads to breaking of the uh, water surfaces as such. And then we spoke about this generation of energy out of wave, and we spoke about the next aspect that comes up, and that is tide. That's a periodic rise and fall as far as the levels of the oceans are concerned, under the influence of the gravitational pull of the sun and the moon. And we have seen how this gravitational pull changes when the sun is say, along with the moon, and the moon at times, it's the eighth day, tends to be the at an right angle, I would rather say, with reference to the earth, leading to what are called as spring tides, which are the highest high tides when the sun and the moon operate together. That's the full moon and the new moon day. And the eighth day from the full moon and the new moon, wherein the sun and the moon tend to pull away the waters towards themselves. And that is called as neap tide, the lowest low tide. As such, there have been a few questions yesterday. We will be taking those questions as such. I was just revising what all we have done till now. And these are the various types of patterns that you would tend to have as far as tidal tides are concerned. Low latitudes, that's around the equator, you're going to have semi-diurnal tides. Semi-diurnal means you're going to have two high tides and two low tides near the equator. As you move away from the equator, you're going to have one you're going to have too high and too low, but but with successive high tide levels that are very different from each other. While as far as very high latitudes are concerned, you would have only one high tide and one low tide as such. Okay, so that was another thing that we did, and then we went into trying to understand the potential areas that could be useful as far as harnessing tidal energy is concerned. And towards the right side, sorry, towards the right side, you have actually a model of how tidal energy generation center would be, or a station would be look like. All the blue areas that you see in the world map towards the left are going to be high potential area as far as tidal energy is concerned. And you'll see that most of them are to do with the configuration. Okay, you'll see that you're going to push water into a narrow region. Obviously the tidal ranges are going to be high, so an obvious fact for high potential areas as far as tidal energy resources are concerned is that the configuration of that particular area is going to play a major role as such. Here were a few questions that were posted yesterday, and in this regard, before I go to the clips that I have ready for you all, first was what about hydroelectric power station? That's what Rutuja has asked. I'm not absolutely clear as to what the say the direction of the question was. So if Rutuja is there with us today, she would just throw some light upon this particular question. What about hydroelectric power station? If
So
she's
I
not
meant to
there, yeah,
ask,
yeah, please go ahead.
uh, how is the energy how is the energy created by hydroelectric power station uh, from water resources?
Okay, okay, okay. It was so very obvious that you could have that particular question when we were discussing about tidal energy, and that's why I thought it was the question, but then I just wanted to get some clarification from you. Now, remember that there is a bit of difference as far as hydroelectric power, let us say the hydroelectric power stations are concerned on one side and tidal power stations are concerned on the other. Okay, when we say hydroelectric power, you'll see that you are releasing water from much higher locations to a lower location. Okay, and this could be some tens of meters, at least some tens of meters as such. And all the dams that we construct, okay, they make this difference in height. This is in technical terms called as, they create a gradient within the water. I did speak about this yesterday also, but the gradient here is very very steep, I would say, and making water fall from this height to a lower height. When the water rushes, you're going to make it run through gadgets which are called as turbines. And it is when the water rushes through these turbines that electricity is generated. This is how hydroelectric power station is concerned. An obvious question would be then, how is it different from tidal power? The basic difference, let me tell you that the logic behind generation of power is the same. Okay, generation or creation of a gradient and movement of water from a higher level to a lower level. But you'll see that as far as a tidal power station is concerned, it has to be very long. Okay, it has to be very long, one. Secondly, it has to be built within the highest high tide and the lowest low tide. It's not everywhere that you can construct a tidal power station as such. And as I said, that the gradient in a tidal power station is concerned, it's going to be significantly less. You'll see that when we spoke about this yesterday, sorry, we just enlarge it for ourselves. Okay, you'll see that the height, the head height as it is called, okay, the highest water in what is called as the tidal basin, and this water is going to move back into the ocean. This difference in gradient is used to actually make generate electricity as far as tidal power is concerned. I would say that as far as this tidal barrage as it is concerned, it could at times be required to be several kilometers in length, which is not so the case as far as hydel power stations are concerned. As far as hydel power stations are concerned, uh, these could be narrow dams which could say block water at a particular level, and blocking of water obviously leads to rise of the water level behind these dams. And once the dam is full, you can allow the water to run through the gradient, thus generating electricity as such. The principle remains the same, but the methodology is different. Is how I would, in a very short description, give you the difference between a hydroelectric power station and a tidal power station as such. The second question was, sir, if a tsunami occurs, what will the foundation part, which is firmly put on the seabed, remain where it is? Uh, and will we be able to generate more energy out of those waves as such? This again is an interesting question, and here I would say that, just let me make some space if I need some. We did see that small clip as far as generation of electric power out of waves is concerned. I would say that there would be a few ifs and buts as far as this particular question is concerned, because as the very reason that wave wave power generation is not very popular, because of these very reasons that you have identified in your question as such. Okay, though we say that they are firmly embedded as far as the seabed is concerned, it would remain to be seen as to how strong this uh, connection, or this foundation of this particular gadget is, because it's something that happens on the move. So there is always going to be a risk. If you're going to have a strong wave, leave aside a tsunami, even a strong wave could be dangerous as far as these gadgets are concerned. And as the latter part of the question is that, will a tsunami be able to generate more energy out of these huge waves? Remember that if this is the level of the water and you have that gadget being placed here, okay, it so happens that as the water gradually rises, okay, you'll see that it will come up, and you'll see that the transmitting of the energy will make it move up and down. Now, as far as the coastal parts are concerned, waves normally are generated towards the coastal regions as such. And as far as the surge of a tsunami is concerned, if it is going to rise suddenly, okay, which is going to be many times the height of a normal wave is concerned, it would be difficult. In fact, this huge wave will collapse onto this, and probably we would not have any generation of or you could be exposed to very limited amount of generation of wave energy as far as tsunamis are concerned. Again, it depends on the quality of the gadget, I would say, and how the study has been done as far as the site location is concerned. It's not going to be anywhere and everywhere that you could place this particular gadget. You'll have to identify a perfect location for this. And of course, as I've already earlier said, that it needs to be resistant to any strong weather attacks. Leave aside, again, I repeat, leave aside tsunami. Basically, because you'll see that even if you say have been along the western coast of India, okay, if you've been to Konkan particularly, in different seasons, you'll see that the aggression that you see as far as the waves are concerned is going to be different. It's going to be very smooth during the winters particularly, and it starts getting stronger during the early months of the summer, and during the southwest monsoons you'll see that the waves are going to be very, very strong as such. So you have to be very careful, and a lot of research needs to be done before letting loose or fixing a particular gadget which is going to give us wave energy at a particular location. I hope that satisfies your uh, query. The third was by Chandralekha, and she says that for tidal bulge, centrifugal force is also responsible. Yes, absolutely. I had purposely not taken it up yesterday because I thought that that would not, if that is rather not a requirement as far as your syllabus is concerned. But since the question is asked, I would, sorry, I would be tempted to answer that now. If this is the Earth, okay, and let us say somewhere here is the sun, and the sun is going to pull the waters towards it. I'm sorry, I'm drawing on it, but the part is here, so that should not be any problem as such. So you'll see that when we speak about the centripetal force, that's the gravitational force, of course, you'll see that it is with reference to the center of the Earth. So you'll see that the gravitational force versus what is called as the centrifugal force. What goes towards the center is gravitational, what goes away is centrifugal force as such. And centrifugal force, we all know, is generated out of an angular momentum or displacement because of the rotation of the earth along its axis as such. So while say the gravitational force of the sun is going to pull the water on the side facing it, because of its gravitational force, remember that okay, the other side, okay, the exactly opposite side of this particular location is going to have centrifugal force. Centrifugal, while this is going to be attracted by the centripetal force, the gravitational force, which is attracting water to off the face, which is towards the sun, which is facing towards the sun. And while that part, which is exactly opposite to this location A, let us say this is A dash here, will be affected by what is called as centrifugal force instead of centripetal. And that is basically because of the rate at which the earth rotates and it sends out objects as such. Okay, so uh, we have time only for that. We actually have this theory, which I think was given by a very famous scientist. If I'm not mistaken, it should be Newton, but let me not commit the name. Uh, this is the theory. This actually is the theory as far as the gravitational force and development of tides are concerned. Uh, with this information, I would just come out of the scenario here, and let me now bring up a few interesting. One that we saw yesterday itself is this. Let me again replay that for benefit of all students. Sorry. Yeah, this was the one we started with yesterday, a short one. I'll play it for you. This doesn't have commentary. You'll have to read through the. Okay, this is what we were speaking about right now. You'll see that it's very gentle, so you'll have to identify a place where this float can be put up. Waves should not be very strong. Okay, such areas would be difficult for putting all this because it tends to be costly also, and you can't afford to lose them. So that is how this is done. This is the foundation, and all that cost needs to be economical as well. So they've put it here, and we'll stop there. Then let us check how tidal energy has its role to play. Where was that? Yeah. Let me share it. Let me put it on a larger scale and let me play it for you.
Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential
This is the one that we have seen in the diagram.
energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
So these were a few interesting facts, we should say, as far as understanding tidal power is concerned. We just did one of them, but they did show us the other two types of generation as far as tidal energy also is concerned, some specific requirements as far as placing up a particular plant is concerned. There is a bit of environmental concern also. And could anyone please point out that environmental concern as far as tidal power generation is concerned? Just in case you can think of any environmental impact of this whole scenario.
Sir, there is no greenhouse gas emissions.
But that's a positive thing. I want something negative.
I think it impact on aquatic life.
Yes, exactly. You'll see that all along the coastline, okay, you have different types and diversity as far as marine life is concerned. And if you are going to change the whole scenario, okay, that will bring about a huge change as far as the ecosystem in that particular location is concerned. While the sea waters are actually habituated to rise and fall regularly with the tide, what you are doing is you are building a barrage in between, and then you're going to make the water stagnate on one side. And it may so happen that all along with the water, you'll have the life, the marine aquatic life, which is going to be transferred onto this side as such. And we have to actually study what impact of this holding is concerned. That's one thing. And you'll see that if the water is going to pass through these turbines, obviously it's going to hurt these organisms which would move from one side to the other as such. Okay, and as I said, that unlike a dam, which again has its own negative impacts as such, a tidal barrage is going to be several kilometers, so it's definitely going to affect the ecosystem along the coastal regions as such. So that was a point to be made. Yes, any additions?
So may I tell something?
Yes, please.
Sir, the negative impact of tidal power energy is water quality and sedimentary processes.
Definitely, yes. Okay, you'll see that unlike river water, wherein you'll see that even if you grade the river water, the water which is going to be towards the top of the dam wall is going to be relatively sediment free. त्याच्यामध्ये जो गाळ असणार आहे, okay, that sediment is going to be very low. On the other hand, you are building a tidal barrage and you are making water to move beneath that. Now, when you're going to make water move beneath that, it's going to carry a lot of sediment, and this sediment could come on one side, and it could block the turbines. You'll have to clean the turbines regularly. So that's going to be an additional say difficulty, technical difficulty as far as tidal power is concerned. So both wave energy as well as tidal energy is concerned. Both of them are have had limited success as compared to the other sources of energy, particularly when we compare it to thermal. And an interesting point made by the commentator in the last documentary was that as far as power generation is concerned, many a times it has to be and that's a basic advantage that thermal power has over other power stations, in the sense that you can bring up, you can step up the production or you can step down the production as regards the say the requirement, the demand is concerned. Say for example, during the summer times, obviously the requirement is going to go up, and during winter times the requirement may go down, only if you are in the warmer regions. If you are in the colder regions, obviously you are again going to use energy to warm your houses as such. But you'll see that say tidal or tidal particularly is so very periodic that you'll have to wait for the next sign as next round of the tides to come up. As such, there was one more question which has come up, and Nupur says that, sir, can it be oil leakage the negative point? Oil leakage, I would say, if you are referring to oil leakage with regards oil tankers, no, it will not be connected. But then if you are referring to oil leakage during the maintenance of these turbines, yes, definitely that could cause additional source of pollution as far as the whole setup is concerned. Uh, with regards a particular phenomena that I would be showing you now is what is called as a tidal bore. Okay, you'll see that tidal bore is very similar to a tsunami, but while a tsunami strikes along the coast more, you'll see a tidal bore actually increases into the interior parts of a creek as such. It would be best understood once we see it, and let us then discuss about it. Let me bring up a tidal bore. There are two short clips. I will just share both of them, and let me see. Yeah, here it is. Let's watch this. They're waiting for the tidal bore. They're going to chase the tidal bore into the interior parts. Started to climb. Water starts rushing. The water starts rushing into the creek gradually to build up. It started surging into the creek. These people have to be very trained because it's very risky to chase the tidal bore. Can run into several kilometers into the creek. Interesting to see water piling up within water. water destructive and nice. That's why we have to be careful with it. Be careful about it. Blocks the water, and that's why the piling water creates a huge wall of water, and that's what is a tidal wall. We have one more, and it's very interesting. We are known about the Chinese people, and you just can't imagine how and what Chinese people can get along as far as tourist attraction is concerned. And this is one such clip from China that of a tidal bore, of course, and tourists are waiting for that.
万马奔腾。好的，此刻我们看到潮水正在翻越钉子坝。那和我们前2天观察来看哈，因为受到台风的影响。
You'll see that because the earlier one was actually taken in a safe area, okay, the actual impact would not have been seen. But when you see this, you'll see how the water is going to lash the land part as it climbs as a tidal bore.
所以这几天钱塘江上游的降水量是比较大的，那么它的。
The advance of the tidal
江
bore.
中心的潮水马上就要撞坝了。
Now you can see
第
the
一波
impact.
溅起的潮水超过了10米。
It's not going back, see, it's climbing. That's the difference between a normal wave.
现在潮水正在由南向北依次撞坝。
And you'll see that it will reflect and deflect from various angles. And it will keep on climbing.
我们可以看到，跟撞坝前的 S 型曲线不同，现在潮头已经被切成了好几个部分，而每一部分都卷着江底的泥沙，咆哮着冲了上来。
Just imagine the intensity with which the water is being forced.
That's 冲天一击，可以感觉到潮水似乎想从江中跃出来。 欲与天空势比高的感觉。刚才我们可以看到，我们在
That's about it. Let's go back to a small section that is remaining, and we should be in a position to finish it today, fortunately. Just a moment. Well, this is to do with a few things that we need to. Why have we studied oceanography? Why is it a part of geography? Why is it that we learn it otherwise also? You'll see that what you see in front of you is the world map and how people tend to have a perception about the oceans as such, given the fact that oceans occupy 70% of the surface of this particular planet. It was at some point of time believed that the oceans have were huge storehouses of various energy resources, primarily fish and then the other marine organisms. And now, of course, we are trying to harness energy and so on and so forth. And with the advent of the industrial revolution, and I would say with the exploration voyages that we had, the Europeans conducting them into different directions in different parts of the world, eventually led to a lot of problems that we are now facing as far as these ocean water bodies are concerned. What are the major activities? This is actually again a small clip that I had seen on the net, but I'm not able to track uh, uh, the URL of this particular clip. It was an extensive 15 to 16 minutes discussion on what man is doing, as far man has done rather, to this whole system of oceans, oceanosphere, you could say. Okay, just a few of them. Okay, you'll see that it is leading to a lot of extraction of a lot of global resources or oceanic resources. One of them, of course, here is extraction of oil. Okay, Bombay High, our very own Bombay High, is one example of that, and it's going to be a few thousand meters deep, and oil leakage could happen at these sites also. Then illegal, unregulated, and unreported, okay, accounts for nearly 20% of the global wild marine catch. This includes, say what can be referred to as what are referred to as rare species also as such. And unfortunately, rare species do fetch a lot of a hefty price in the smugglers market as such. Having done this, okay, you'll see that poor countries, including India, extend a lot of subsidy to its own fishermen as such. So you'll see that nearly $35 billion of subsidy every year is extended worldwide to fishermen around the globe as such. Okay. Uh, as we said, illegal, unregulated, and unreported fishing costs what around $235 billion a year, and mismanagement of fisheries. Okay, mismanagement of fisheries causes 50 loss of $50 billion a year as such. Okay, this is one aspect to it. But then going to the broader aspect of it, you'll see that. As I said, that there have been times, or even today you will see that majority of the population on the surface of this planet is hardly bothered about what we are actually dumping into the oceans as such. If you check the impurities that land up in the oceans, 80% of them are land oriented. And to start with, naming a few of them, you'll see that excessive use of fertilizers, sorry, excessive use of fertilizers as far as agricultural practice is concerned. Similarly, excessive use of pesticides also tend to be dumped into as such. Okay, you'll see that many cities, okay, in India itself, you'll see that the so-called four metros are concerned. Three of the four metros are in the coastal location, and the sewage of this particular these cities is directly dumped into the oceanic waters. Not only that, you'll see that garbage is also dumped. Along with that, you'll see that if you're going to have say radioactive waste has been a significant problem as far as oceanic waters are concerned. We just don't have an estimate of how much of this radioactive waste has already been dumped into uh, different sections of different oceans by the developed countries of the world also. Then you'll see that oil leakages, and one of the most common polluters is plastic. Okay, it tends to be dumped into the oceans as such. What does this lead to? This leads to increase in temperature of the oceans as such. It increases the acidity of the oceanic waters as such, and both of them leads to loss of oxygen. Okay, you'll see, we know that as far as oxygen in water is concerned, or what is called as dissolved oxygen, that is definitely much lower as compared to free oxygen. So if you have 21% around us, we have much less percentage of oxygen dissolved in water as such. Okay. And these actually are called, okay, warming of the waters, acidification, and consequently loss of oxygen is called as the deadly trio, which are affecting the health of the oceans as such. Okay, not to forget the dumps, okay, the waste that is dumped out of ships, tankers, which tend to travel into different directions, because you'll see that as far as ships are concerned, or water transport is concerned, or ocean transport, ocean surface transport is concerned, is supposed to be the cheapest means of transport. So most of the bulky commodities around the globe are transported by using ships and tankers. Obviously the staff on these huge tankers, okay, and let me tell you, these are literally huge. The word huge would be dwarfed in front of the sizes of these tankers. If you see them, huge sizes of them, it's like a city traveling across the waters as such. Okay, these are just to name a few. Okay, of course we do go into the details of this if we are going to do, when we do oceanography as a subject, as far as our postgraduate students are concerned. But as I said, the limitations of your syllabus will not we should not go, I should not burden you with more content, and of course we should stay within the syllabus as such. Having said this, what can be done? Okay, you'll see that one of the first things that needs to be done very seriously is high sea governance, because you'll see that as far as political limits are concerned, uh, every country owns, literally owns 200 the seas up to 200 and 200 nautical miles. Okay, as far as the sea beyond that is concerned, beyond 200 nautical miles is concerned, it is high sea, and it is believed that it is under the domination, it's open to all countries. And you'll see that the very fact that this particular individual has a head of a fish, okay, you'll see that fishing has been seriously hampered, okay, in high sea. And in fact, even so to say, countries like Japan, which are known to be, which are actually have, I won't say known to be, but they have a very clean environmental face as far as others are concerned. But you'll see that they are illegally actually bringing about a lot of changes as far as high sea fishing is concerned, particularly as far as whales are concerned. Okay, till recent times, whaling as an activity was seriously banned, and as a consequence, the economies of countries like Japan, Sweden did suffer. But then recently, what has happened is they have been in connivance, I would rather say, with the poor countries, and they have literally bought the votes of these in the United Nations, and they have come up with a regulation which has eased out whaling as an activity in high sea waters as such. Okay, as you'll see that literally 90% of the countries of this world will have some part of its waters touching the ocean waters as such. It becomes very difficult that the United Nations Development Goal looks at saving the quality of waters and resources as far as oceans are concerned. As such, a serious thing that needs to be done is banning of subsidies that is given, okay, because more subsidies means more pollution. Of course, bans will not stop here. Banning of unregulated ships and fishing is something, again, very necessary as such, okay, particularly in areas wherein you have high density of trading activities and you have huge number of ships passing those areas. Now, an obvious question would be that if a tanker passes the ocean waters at a particular location, why should that be a dreadful thing? Huh. As we saw in the lecture, today's lecture earlier, that even a small generation of tidal power could cause serious issues as far as ecosystems is concerned. Regular traversing of oceanic waters by huge tankers, the cleaning of this, and particularly those oil tankers which account for a huge amount of transport of oil resources, you'll see that these oil tankers unfortunately are not brought to their docks to be cleaned as such. In fact, conversely, what is done is these oil tankers are taken into deep waters. Once they have delivered the oil at a particular location, they need to be cleaned. So they're taken into oceanic waters, and high speed jet engines are going to be put to use as far as cleaning the whole tanker is concerned. And where does the wastewater goes? It is dumped into the oceans as such. So that is what we mean by unregulated shipping activities as such. A very serious issue is the plastic pollution. Okay, dumping of other garbage also, but within the garbage, you'll see plastic is a very serious concern, and we need to, as citizens of this particular planet, as animals on this surface of this particular planet, a serious thing that needs to be taken up. Of course, all of these are serious enough, but I would rank this amongst the first, that we should end plastic pollution as such. All this will be possible only if we bind safety and environmental norms as such. We also need to have monitoring boards. Okay, just like in India, you have the Coast Guard, which guards that. Of course, initially, of course, these monitoring boards were for smuggling, but I would say that we need to extend the responsibility of these boards to actually look into dumping of waste, or dumping of particularly nuclear waste, and smuggling of unique varieties of organisms from one part to the other, unregulated, and say, ship travels and fishing as well as such. Okay, and a high sea regeneration zone needs to be created as such, so that such areas can be called as protected areas, and you can restore the health of, to some extent, of course. Okay, now all this is very much in requirement, basically because even with the present number, we are facing all these problems, and within the next uh, 30, 25, 30 years, say by 2050, we are looking at a population of 9 billion, and most of this population is again going to reside in coastal areas as such. We need to actually come up with solid governance, sustainable management, and effective conservation techniques. If that is not done, it's going to be a serious issue for all of us. Okay, because this eventually is going to affect the global climate. Okay, and this global climate is obviously going to cause a climatic change, and this climate change would adversely impact various issues, not only on the ocean surfaces, but the remaining of the one fourth of the surface of this planet, and that is land as such. So this, in short, is actually uh, what all this is about: oceans, ocean waters, ocean surfaces. And as a consequence, we need to take proper care of all the three. I would in fact say all the four, excluding biosphere. Okay, the land, it needs to be say protected from pollution. The air needs to be protected from pollution. The water also needs to be protected from pollution. The more we take cognizance of what is happening with them, the more possibly we would be in a position to actually try and understand what is wrong and how can this be corrected as such. Because unless and until we correct this, we are actually going to be the direct, say uh, this is going to be the the species which is going to be affected by climate change, and so on and so forth. I always tell my students that why is it that recently we have actually grown to this particular number. Okay, and I remind people of what happened to the dinosaurs around 150 to 200 million years ago as such. The possible climatic conditions were the best for the dinosaurs at that particular point of time. Similarly, the possible climatic conditions, I would say, are best for the human race at this particular point of time. The very fact that human beings have developed scientifically to this particular level and evolved to be one of the most smart organisms and species on the surface of this particular planet is the fact that we are living in the best of the climatic conditions that should be suiting human habitats. But unfortunately, human beings themselves are nowadays responsible for disrupting the quality of the environment around us. And obviously you'll see that if the say the whole scenario of land, wind, and land, air, and water tends to get polluted, an obvious logical output of this is going to be that these very things, if they are not maintained in their optimum levels, they may be they may cause a resultant impact on the life of human beings on this particular planet. So I always remind my students that it is not the earth that we have to save from pollution. It is actually human species that we have to save from ourselves. Okay, our overutilization of various resources, the pollution, the various types of pollutions that we are a cause to, is something that we need to seriously think about. And unless and until we do that, it's going to be very difficult as such. So that's all from my side. I believe your exams are going to start from the 7th of Feb. If you have any further queries, you can obviously post them on our WhatsApp group, and I'll try to answer them as such. That's all I would believe from my side. Yes, I am actually still assessing your assignments, and that would be some time before I actually mark your assignments. And by the way, we have received your marks out of 20 MCQs also. So very soon I would be giving out those marks as well. So that's all from my side. If you have any queries, you could very well ask them from your side as also. Otherwise, that's all. I wish you all the best as far as your exams are concerned. And till we meet for the second semester, it's going to be bye from me. Thank you very much for being very good students. Okay, I wish you all the best.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.